Today we'll be discussing rotational motion in orbits, as you can see. Alright, first we'll define what that actually means. Because it sounds complicated, but it's really simple. Alright, here we go. Rotational motion is what makes the world go around. Like literally round, like a circle. Alright. We'll be talking about rotational kinematics, dynamics, kinetic energy, and angular momentum. In our daily lives, we see bike wheels, disc, and the earth, which rotate. And we can define the rotation. We can find the rotation of these objects with rotational motion in orbits. So, first, for rotational motion, the object needs to be round. From the center to the edge, it's R. If you were to have something like pulling it up this way, you can find theta. I'll draw it out. So if you have an object going like this, you can find theta. And then this will be your length of whatever string or anything that would be pulling it. And if L, your length, equals R, then theta equals 1 radian. Alright, moving on. Alright, important keywords, which is the vocabulary that you would need to know. Number 1, radian is the distance moved around a circle compared to a radius. Angular displacement, change in angle in the radius as the object rotates. Angular velocity, change in angular displacement divided by the change in time. Angular acceleration, change in angular velocity divided by time. Lever arm. Number 5, usually the radius used to be used to find torque. Center of mass, the point on an object that moves in the same way that a point particle would move. Torque, the tendency of a force to cause an object to rotate about an axis. Rotational equilibrium, when the net torque is equal to 0. Moment of inertia, the resistance to rotation, and it has an equation to it, which is I equals mr squared. Inertia, which is I, equals momentum times radius squared. Alright, moving on to the last thing is Newton's second law. The angular acceleration of an object is directly proportional to the net torque and inversely proportional to the momentum of inertia. Alright. These terms follow certain equations, which are quite similar to those of kinematics, also known as linear motion. So let's go here and write down the equations. Newton's second law. If we were to have linear motion, the equation equals F equals ma. Well, we are working on rotational motion, which equals T equals AI. Acceleration, time, inertia. Moving on to momentum. Well, linear is P equals md. But we're looking at L equals I. Looks like a W. Moving on to work. Linear has work equals force parallel to your distance. Here, work equals time with the change of theta. Kinetic energy. We have K equals 1/2 mv squared. In rotational, we have 1/2 I squared. Power. We have P equals F E, and over here we have P equals T, the little W. It's not W though. Velocity. We have V equals change in distance over the change in time. Over here we have signifies velocity equals change in theta over change in time. Acceleration is A equals change in velocity over change in time. And over here we have acceleration equals change in velocity, which is this little W looking thing, and change in time. Displacement is D equals velocity initial, change in time, plus 1/2 acceleration time squared. Over here, we would equal theta equals initial plus 1/2 a t squared. Notice how this part and this part doesn't change for either equation. And this also doesn't change, we just use different symbols. Very simple. Alright, now that we know the equations, we can start solving problems. Here a problem over here. An object attached to a 0.5 meter string does a rotation in 1 second and finds A, B, C angular velocity. Alright. To find the period, if the object does 4 rotations, in 1 second will equal 4s, which is f. Found frequency. Now that you found frequency, t equals 1 over f. So then this will equal 1 over 4, and that is your period. For tangential velocity, we will use v equals 2 pi f r. We have 2 pi. This is a 4, and this is 0.05. Alright, so in the end, after you multiply all these out, we get 12 meters per second, which is velocity. Alright, moving on. Your angular velocity is equals 2 pi f, which then turns out to be 2 pi 4, which we got from the problem before, part B, and turns out to be 24 radians per second. Those are your answers, and thanks for watching.